Hi there. In the last video, we had a look at transformations of quadratic functions. And what that means is that we can take the base graph y equals x squared, like I've got written here, and I can sort of build up that base graph by changing the inputs and outputs, and it gives us a brand new function. So for example, if I take away h from x and then square it, I'll end up doing a horizontal shift of the base graph. Then if I add k to the output like this, then the graph will go up and down. A combination of these two things means it goes any old way. And then the value a multiplied to the x minus h all squared means that the graph will dilate either by squishing towards the y-axis or stretching away from the y-axis. They're called dilations. And if a is negative, then it will also flip. Okay, so if you remember that in a base graph, the turning point is 0, 0, then the fact that this translates it across and this translates it up and down means that h and k becomes the brand new turning point. So the turning point, h comma k, is where the turning point will end up being. So that's why this is called turning point form. And we last encountered turning point form in a real sense in the algebra unit, where we took a general quadratic and we manipulated it until it was in this form here. Now you can see why it's useful, because in turning point form, we can get the turning point straight away. And that may be the critical thing we want to find. So that's why this dot point is really important. All quadratics can be written in turning point form. And that means that if you're given a quadratic not in turning point form, you can use completing the square to turn it into turning point form so that you can graph it. Whether you'd want to or not is another question. We'll cover that in a different video. Let's have a look at example. I'm looking at slide 20 now, and I've got y equals 2x squared plus 4x minus 2. So first things first, we're going to put it into turning point form, and we do that by taking the first two terms of the quadratic equation, that's the x squared term and the x term, and we take out the value that's before the x squared, that's the a value if you like, and using square brackets we write the rest of it down. So x squared, because 2 times x squared is x squared, plus 2x because 2 times 2x is 4x, and we leave the minus 2 out here. You might have noticed that 2 was a common factor for all three, but I still haven't taken out that common factor here. And that's because later on we then have to end up expanding it anyway. So I leave it out because it's a bit pointless otherwise. That's equal to 2 outside of. Now we're going to do the completing the square by halving the x coefficient. So the x coefficient is 2, halve that to get 1. So it's going to be x plus 1 all squared, and then we subtract the square straight away, minus 2. And then we expand, so that's 2 outside of x plus 1 all squared. 2 times minus 1 is minus 2, minus 2. And that gives me 2 outside of x plus 1 all squared, minus 4. Okay, so that's fine. So that gives us our turning point form. Once it's in turning point form, we can now work out the critical pieces of information. And for a quadratic, there are really 4 critical pieces of information. Number 1, is it smiley or frowny? Officially, we call that concave up or concave down. And the sign of A will tell us whether it's smiley or frowny. Number 2, the y-intercept. Number 3, the x-intercept. Number 4, the turning point. I'm going to try and squish it all onto this slide. Wish me good luck. Now, number 1, the shape of the graph. That's often what it's called. The shape, we've got a equals 2. Therefore, it's going to be a smiley graph. It's going to be concave up. It's also going to be quite thin as well. So remember, as a gets bigger and bigger, the graph gets thinner and thinner. Number 2, we can look at the y-intercept. That's okay. That just means x equals 0. And when x equals 0, we've got y is equal to 2 outside of 0 plus 1 all squared, minus 4. I reckon we can do that in our head. 1 squared is 1, multiplied by 2 is 2, minus 4 is negative 2. And so we've got our first point here, 0, negative 2. The x-intercept is probably the hardest bit here. Let's give it a crack. For the x-intercept, or intercepts, we let y equals 0. So we've got 2 outside of x plus 1 all squared minus 4 is equal to 0. Now we're going to just go about solving it. So I'm going to add 4 to both sides. I'm going to divide both sides by 2. I'm going to square root both sides. Yeah, plus or minus, of course. And so x is equal to -1 plus or minus the square root of 2. So officially, that makes the coordinates -1 minus root 2 and 0. And we've got -1 plus root 2 and 0. That's the official, but they're pretty horrible. So it would not be a bad thing at all to get your calculator out and maybe have a crack at just working out the decimals as well. You can write them off to the side. You can write them officially. They're probably not going to be too many complaints if you just use an approximation with this kind of stuff. So what I can't show you really is that I'm putting it into the calculator here to get the value. So I'll just come back with the actual value itself. So -1 minus root 2 is -2.41. And -1 plus root 2. It's good telly, isn't it? Is 0.41. Yeah, 0.41 and 0. So there's our 2x intercept. So our fourth piece of critical information is the turning point, and that's where you can go, that's easy, isn't it? Because the turning point is given to us when it's in turning point form. We've got 2 outside of x plus 1 all squared, so the x coordinate is -1, and then we've got -4 as well. So that's the good thing about putting it into turning point form. The turning point is actually really easy to work out. Okay, so sketching it. I've only got a tiny bit of room here, I'm sorry, so forgive my little squishy graph. So I've got what, -2.41, which let's just say it's going to be here. And I've got 0.41, something like this. I've got a turning point of -1 and -4. So -1, -4, let's call it there. And I've got a y-intercept of -2, which is, say, about here. So again, on glass, I find it very difficult to do a decent sketch, but I'm going to come through here. I'm going to loop around, go through my y-intercept and loop up. It's not the best sketch, but it's okay. And again, just to confirm, I'm expecting a concave up. I've got a concave up graph. It's cutting through the right points, so it's okay. So that's how you do completing the square. So you've got some problems to do from exercise 3E, so give them a go. Meantime, I'll create a second video which will go through a different kind of quadratic for you to graph.